All right, up on the board, I have a sequence that should be familiar to us. What do we call this type of sequence? Arithmetic, arithmetic, whatever you call it, it's the same thing. How do I know? What's so special about it?
Same numbers added every time.
Same numbers added, right? I add 3 every time. All right, so that's arithmetic. I have this formula off the formula sheet that I use. I'm not asking you guys to write anything down, but here's the formula we've been using for anything that's arithmetic, right? Okay, I'm going to introduce one more type of sequence today, and that is what happens when we multiply instead of adding by a certain number. All right, so arithmetic, I add. Let me introduce you to geometric. All right, geometric is when I multiply by a certain number. All right, so look at my first sequence here, 32, 8, and 2. That is geometric. Now, the first thing I know kids struggle with is you can't find what you're multiplying by. Right? What you guys can probably tell what I'm dividing by, though, right? And what am I dividing by? 4, right? Well, I don't want to talk division. I only want to talk multiplication. So if I'm dividing by 4, that's the same as multiplying by 1/4. Okay, 1/4. Now look, even that might be too confusing. And I get it. That might be too confusing. So here you go. Here's the, I hate to say trick, but here's the way I want you to find what you're multiplying by if you can't see it right away. Pick any term but the first right now in my sequence. Pick any term but the first. 8. Okay. If you ever want to find what you're multiplying by, you take any term and divide it by the previous term, which for us would be what?
2.
Oh, 30. If I take any term, you guys told me to take 8 and divide by the previous term, 32. And if I go to my calculator, and it reduces for you 8 over 32. Okay, I'm now multiplying by a 4. Okay, so please use that today if you are unsure what we're multiplying by. Take any term and divide it by the previous. Now, let's throw a name to that now. If you remember, I'm adding 3 to this arithmetic one, right? The one I showed you. What do I call that, by the way, what I add? Common difference. What you multiply by is called a common ratio. Common ratio, and that's an R value. D was common difference. Common ratio is what I multiply by, and that's an R value. So can you guys real quickly right now, can you find the next 3 terms in my sequence now that we know I'm multiplying by a 4th? Okay, so multiply 2 by a 4th and keep multiplying by a 4th for me. You're going to get some fractions. So are we finding the and I won't ask anybody here, next 3 terms, 1/2, 1/4, and not 1/8, sorry. 1/8 and 1/32. Yep, good. Questions? Okay. I keep going back to arithmetic because I want to compare them with you. We can use this formula to find a lot of things for arithmetic. Geometric has its own formula. Look on your formula sheet for me because it's there as well. This is not a formula you need to memorize. Everyone see where it says geometric sequence. We're not at series. We're not adding them up until tomorrow. Everyone see where it says sequence. All right, I think probably that box I gave you there is probably a little too small, but if you want to squeeze it in there, that's fine. Here you go. For a geometric sequence, here's where I live. Here's the formula. Any term can be found by taking first term, multiplying it by the common ratio raised to n minus 1 there. And I go, oh, that's not previous. Remember, that's not previous, right? The n is whatever term I'm trying to find here. Okay? So that's the formula we're going to use. It's on your formula sheet. No need to memorize it. All right, let's use it. Let's use it now. Find the 17th term of this geometric sequence. 17th term. And I don't want you to write out all 17. That's ridiculous. We have a formula now that can do it for us in one step. And remember, this is no plus in between. This isn't arithmetic. All right, 17th term, so A with a subscript of 17 equals 1/16th, first term. Everyone's good? 1/16th. You want to put that in parentheses? Not. It's your call. Okay, R value, what I'm multiplying by. Don't even make it a discussion. If you're confused, take any term, divide it by the previous. There's your common ratio. And in this case, it would be?
4.
Is everyone comfortable in multiplying by 4? That's my ratio, what I multiply by. And now I raise it to, what's my n? 17, whatever you plugged in for the subscript there. 17 minus 1. And again, I always like to just put it in one step. Okay, put it in one step.
Wait, I'm confused on how we got 4.
4? Yep. Remember, that's my R. That's my common ratio, Gabby. That's what I multiply every term by to get the next.
Okay.
So
Wait.
even if I can't see the pattern, I'm going to take 16 and divide it by the previous term. That will always get you your R value.
Okay.
All right. Always. And we got a large number here, huh, kids? Little 268 million. 435,000. And you know, how can it be? That can't be possible, that large. You're multiplying by 4 every time, remember? And we're going up to the 17th term, so it's possible. Any issues? Okay. I'm at number 2. I'm asking the same thing, different notation now. First term's 5, R equals 3, and N equals 6. Find AN. Well, I know what N is now. So really, what am I asking for in this question instead of coming out and asking it like I did in number 1? Find the 6th term. Yeah, find the 6th term now. Good, good. So that'll be the first term, 5. Oh, wait a sec. Oh, I should have asked you guys this. We have 2 types of sequences now. How do I know I'm dealing with geometric versus arithmetic? And don't tell me, oh, it's geometric day. Thank you. Yes, thank you. Because on Friday, when you take the test, I'm not going to point and say it's geometric. We have to identify, oh, he's giving me an R value, so this makes it geometric. Everyone see that? All right, good, because now we got 2 to decide between. And what do I have here? 3 to the 6 minus 1. So my 6th term, what do we got, 1,215, if I'm doing the math right? Yeah. Any issues using this geometric sequence formula? All right, let's use it a different way now. We're finding a certain term in the sequence. Let's use the formula now to find the first term. Okay, use the formula to find the first term. I see it's geometric. I came out and told you. So I know I'm going to my formula here. All right, can you kids help me fill it in and solve it? So let's start. AN will be
20.
any term, right? Any term. We do know any term. It's 20. First term's just going to stay A1. R value of 1/2. Now be careful here. Because I'm not plugging in 20 for that N.
8.
Eighths, right? 20 is the 8th term in the sequence. How's the solving this part? How's the solving? Making sure you're multiplying by A1, so you want to get whatever's with the A1, you want to divide it out, right? Divide it out to undo it to the other side.
How did you go from 8 minus 1 to 7?
I have no idea, Kate. That's a great question. I would like answered too. How about just 7? Always there to call me out, huh? How does 2,560 look?
Yeah.
No? I'm doing, here you go, ready? Look, I'm doing 1/7, 1/2 raised to the 7th. All right, I get 1/28 or whatever decimal that is, but that's with, let me show that step here. So 20 equals A1 times, what was it again? 1/28? 1/128. Now, how do I get rid of it? Divide both. I can have one of two ways. Divide both sides by 1/128 or multiply both sides by 128. Okay? Either way, we should end up with 2,560.
Because I don't know what it's asking.
Questions?
I think it's just you're writing an equation.
All right. Now, I'm going to ask you to do. Go ahead, Dad. Yourself.
I'm getting like 5 over 30. I put in excess for a.
Okay, you're multiplying it by 20 though, right? You want to get rid of it by dividing. If you're going to multiply, you got to multiply by the reciprocal, so you got to multiply by 128 only. Okay, or divide both sides by 1/1.
No, but how would it be for the same one? Because for
Ask me now, number 3, before I go on. Are we all right here? Solving it algebraically. Okay, I asked you to do this. Let's go to 4. I asked you to do this for an arithmetic sequence. Come up with a general formula, an nth term formula, where n stays n. Same thing, guys. I'm not changing the rules. N stays n, but now I'm using a new formula because it's geometric. So for part A, an equals a1 times r to the n minus 1. I just can't have you fall into the trap at the end. N stays n, so keep it an. What am I plugging in for a1? 5. R is what you're going by. If you can't tell, take a term, divide by the previous. 5 as well. What's getting plugged in for this n? N stays n. Here's where I can't fall into the trap here. We're done. There's not a 25 spot up there. We're done. This is all attached. So I cannot multiply that 5 with that 5. We're done. We're done. Congratulations. We're done. That's it. I don't multiply those two. I can't. All right. These are all attached here, so I can't multiply it by the other 5. So that's it. There's your nth term formula. If you want to find the 20th term, the 80th term, now I plug in 80 for n to find the 80th term. Yeah. What, part B here? Yeah, well, part B, I'm missing something now. It's still the same question. Write an equation for the nth term. If you know the 4th term is 3 and the r value is 8. Okay, but there's going to be a problem you guys might see already. N stays n. Right away, what's my problem? Oh, I don't have the A1 value. That stinks, right? I don't have the A1 value. Need it though to plug into the formula. I need that value, and then I have 8 to the n minus 1. So I need your help. How do I find the first term of the sequence now? Just by knowing this stuff here.
You divide 3 by any term. Try and find A1.
You got. I'm letting this just roll. How can I find the first term here if I know the 3rd term or the 4th term is 3, and I'm multiplying by 8? What do you mean plug it in? Go ahead.
Like plug 8, like 3 equals.
So use this formula again to find the first term, which we just did up here. Yeah, absolutely. So here you go. We got to take a time out here. Let's use this formula again. What's any term I know? Yeah, what is it? What's any term I already know? 3 equals A1 times 8. Right now, what's 3's position in the sequence? What's my n value going to be here? 4, right? Because it's the 4th term, so 4. Again, hey, if I'm confusing people, I get it, but all I'm doing is the same thing I did in number 3. This is the same thing I'm doing in problem number 3 to find the first term. Okay, so 3 equals A1 times 8 to the 3rd, whatever that is, and divide it out.
3 over 512.
This just for me.
Yep.
I tried doing like a to the 3rd, right? I got 512, and then I divided 3 by 512.
Yeah.
But then I got like a really long decimal.
Well, just leave it at 3 over 512, because that's our first term. Yeah. Yeah, just here, A1 equals 3 over 512. Yeah. Or you can use the decimal too, Harper, but I think it's a little cleaner doing it that way. Was anybody going to find the first term a different way than what I'm showing?
Is there a different way?
Well, there is, which is, remember the R value is what you keep multiplying by. So if you want to go backwards, just keep dividing by 8 until you hit the first term. So that's the other way, right?
Okay.
I don't care how you get there either. I don't care. Whatever gets the job done. And we're done. There you go. Plop in that 3 over 512 and we are good to go. Okay, we've got one word problem left. A little helium in the balloon. Ooh, 2. Well, I got another one. Oh yeah, I got that last. How many more are there? 3 more? Oh, sorry. All right, I didn't notice those. Yeah. Okay, here we go. Quick word problem. I'm starting with 5,000 cubic centimeters of helium. Wow, great. It loses 1/4 each day.
Yeah.
Write me a sequence that shows how much helium is in the balloon at the start of the day. So we're just writing a sequence now. So we know day 1 is 5,000, right? Day 1, 5,000. Nothing fancy here. Can you guys help me find how much is left? How much helium is in there? Day 2. What do I do with the 5,000 if it loses 1/4 every day? Be careful here. Be careful. I got 5,000 right now, and it's going to lose 1/4 of that. Multiply it by 1/4, yeah. But watch yourself here. 1250 is not my second term. What's that 1250 you just generated? That is how much you just lost, right? We just lost 1250. So read the problem though. What's the problem asking? How much is, right, the geometric sequence that shows the amount of helium in the balloon at the start. So I want to know how much helium is still there at the start of each day, and it's not 1250. So what do I need to do with the 1250 here? Subtract it from 5,000, and that is my second term. So really, it should be 3,750. All right, again, right? Let's keep going. Times 1/4 again. Well, again, that's not my answer, right? That's how much helium I'm losing. So I got to go back and do 3,750 minus that. Not pretty, but I think, can we leave this one as a decimal? I think it'll be easier on our eyes if we leave this one as that instead. I don't care, by the way. You want to leave it as that fraction, that's fine. It's still correct. 2812.5. And go ahead. Keep. You got 2 more days for me. 2 more days. Yep, you're going to get some decimals here, but it happens. Or if you left it as your calculator's leaving it as a fraction, leave it as a fraction. Everyone all right? We good there? No? We all right here with those numbers or no? No, Grant? No? Okay, so here we go. 2, 1. Let me go back to my calculator. Let's fix this. Times a quarter, right? Again, that's how much helium I'm losing. So now I subtract the 2812.5 minus the 703.125, and that's where I got my 2019.375. Good? Multiply that by a fourth and subtract that from 2109 again. All right, guys. Nth term equation now for this sequence. Nth term. N stays. N, here you go. What was my first term?
5,000.
I had 5,000 cubic centimeters in there. Whoa! I'm going to catch all of you on this. Times the R value. Everyone's going to put in a quarter. That's what it lost. You might want to check that. What's our little trick here today? How do I find the R value? Take any term, divide by the previous, and I guarantee you, go ahead, it won't be a quarter. That's how much we're losing. This problem is how much is left in the balloon. So everyone's not going to get a quarter. What you got in your calculator is going to make more sense, which is what? 0.75, 3/4? Because that's how much, if I'm losing a quarter, there's going to be 3/4 of it left. And what should I raise that to? N minus 1. Good. Yep. All right, let's finish on a strong note now. You guys are going to teach me how to do this problem. First term is 3. Fourth term's 24. Find the geometric means, meaning the numbers in the middle of the sequence. You guys did this on your quiz for arithmetic. Now I want you to do it for geometric. So again, I got 3 as the first term, and I want to find the 3 numbers in between. Nope, 2 numbers, right? Before I get to 24, which is the fourth term. And I really don't want to guess and check either, because you never know, it might come out to be a decimal. All right, so what value would it be awesome to know here? The R value. And what formula can I get the R value from? The formula we've been working on all today. I just want to make sure you guys know where to go on your calculator to solve this. AN, any term other than the first, obviously, because we got a spot for that. 24, right? It's got to be the actual term. First term 3, R value is what we're trying to find. What's my N in this case? Where's 24 in the sequence?
4.
Fourth term. Okay, stay with me here because I want to make sure you got this algebra down pat. Now, 24 equals 3R to the third. What's your next move? Divide by 3, yep. And maybe you did this in Algebra 2 last year, I don't know. If that was a square, you tell me to take the square root. But it's a cube, so you take the cube root, and I just want to make sure we're good where to go on our calculator because there's 2 different places. You can do cube root. I always go under math, and it's right there. Okay, I hit the math button on the left-hand side, and it's choice 4. Okay, the other way, I'm not even going to bother. Why? Give you 2 different places. So there you go. You can take 4. We're doing the cube root of 8, and it ends up being 2. So there's my R value of 2. Now use it to find the 2 missing numbers. 6 and 12, and it makes sense because if I do it one more time, 12 times 2 gives me that 24.
How do we know? Is this the first term or is it just?
Yes, 3.12 is the first one because I want to find numbers between them. Yep. All right, I'll do this one too with you because I think something's going to happen again on your calculator. So what are we doing? 3 means between them? Okay, what are you plugging in for AN? 49.92 equals first term 3.12 times R to the, what's my N value here now? 5, everyone, yes?
Yeah.
Fifth term?
Yeah.
Okay. All right, so 49.92 equals 3.12 r to the fourth. Next move?
Divide by 3.
Yep, divide by 3.12, I like it. And we get r to the fourth equals 16. All right, now I got to just show you, what do I do about this now? Well, you took the third root, right? Now we can take the fourth root. Now, anything over 3 on your calculator, you need to tell it what root you're taking. So everyone go to your calc now, hit that math button again. Okay, but now I need, everyone see number 5, where it's got the X in there? You can type in whatever root you want now. So hit number 5 and you can just type in, yep, I'm looking for the fourth root of 16 and it'll do it for you. It'll tell you it's 2. All right. And then multiply everything by 2 up here. So what we got there, 6.24. It's at 12.48. And what's the last one here? What's your last one here?
24.96.
24.96. Okay. Plenty of time here. You guys are going to, looks like the textbook right now. All right, so you guys know where to find those pages. And just like I've always done, you got lined paper on the back to try out those textbook pages. All right, let's get it going, guys.